In this section, we're going to learn about function operations. In last chapter, we talked about how to add, subtract, multiply, and divide polynomials. And you're going to learn in this section that we can do those exact same operations for functions. So if we look at our first problem here, I have f of x equals 6x and g of x equals x to the 3/4 power. My question is asking me to find f of x times g of x. So if I want to find f of x times g of x, I can just take 6x times x to the 3/4. To multiply these, just remember back to our exponent properties that we talked about last chapter. When you're multiplying variables, just add their exponents together. 6x is the same thing as 6x to the 1st power. If we add our exponents, one plus 3/4 is 7/4. So when we multiply 6x and x to the 3/4 together, we get 6x to the 7/4 as our answer. And that's basic multiplication with function operations. Now let's say I wanted to divide two functions. So my second question asks me to find f of x divided by g of x. So to get that, I just need to take 6x divided by x to the 3/4. Again, to simplify, we're going to use our exponent properties. When we're taking x divided by x to the 3/4, we can just subtract their exponents. One minus 3/4 is 1/4. So when we divide these two functions together, we're going to get 6 times x to the 1/4 power. And that is how we divide functions. So now we're going to add functions together. If you notice, I have two functions. I have f of x equals 4 plus x to the 1/2 power, and I have g of x equals x squared plus 2 times x to the 1/2 power. If I want to add these two functions together, I can just add 4 plus x to the 1/2 and x squared plus 2 times x to the 1/2 together. After I add them together, I'm going to combine my like terms. See, I have an x squared. I just have one x squared. I have an x to the 1/2 and a 2x to the 1/2. So I can add those together. Remember, when we add variables, you add their coefficients together. So x to the 1/2 is the same thing as 1x to the 1/2. 1 plus 2 is 3. Then I have 4 left over. So when I add these two functions together, I get x squared plus 3x to the 1/2 plus 4. When we're subtracting functions, just like when we added, we're just going to subtract the components of each function. So now I'm going to subtract f of x minus g of x. F of x is 4 plus x to the 1/2. G of x is x squared plus 2 times x to the 1/2. And again, always be careful with subtraction here. When I'm subtracting functions, I like to put my second function in parentheses because that's going to remind me that I need to distribute this negative sign to both terms. So my second function becomes, after I subtract, negative x squared minus 2 times x to the 1/2. Then again, I combine my like terms. I have a negative x squared. That is my only variable with it to the second power. I have x to the 1/2 and negative x to the 1/2. Those combine to be negative x to the 1/2. And then I have 4 left over again. So my final answer is negative x squared minus x to the 1/2 plus 4. Now we're going to talk about how to find composition of functions. So if you look, I have f of x equals x squared plus 3, and I have g of x equals 3 times x cubed. My question says, find f parentheses g of x. We read that by saying f of g of x. If you notice in our notation here, our g of x is inside the parentheses of our f. Now that is exactly what we're going to do when we're finding our composition of functions. I'm going to take my g of x, the entire function, and plug it in for x in my f function. So I've taken my g function, 3x cubed. I have plugged it in for x in my f function. So it has completely replaced the x. So instead of saying x squared plus 3, I now have 3x cubed squared plus 3. And now we're going to simplify. Just use the exponent properties from last chapter. If I'm squaring 3x cubed, I'm going to distribute my exponent to each term. Not just my variable, but my number. So 3 squared is 9. X cubed squared, so we're taking a power to a power, so we multiply the powers. Becomes 9x to the 6th. And we still have our plus 3. So we just found f of g of x. Now not only can we find f of g of x, we can find g of f of x. So I have two brand new functions here. I have f of x equals x squared minus 1, and g of x equals 4x squared. If you notice in my notation, the f of x is inside the g. So that means I'm going to take my entire f function and plug it in for x in my g function. So my entire function is now going to become 4 times x squared minus 1 squared, because I've taken my f function, which is x squared minus 1, and substituted it in for x. It now replaces the x. So this is now x squared minus 1 instead of just x. And now we're going to simplify. Since I am squaring this, we're going to FOIL. X squared minus 1 is the same thing as saying x squared minus 1 times x squared minus 1. When you FOIL, you get 4 times x to the 4th minus x squared plus 1. If we simplify, we get 4 times x to the 4th minus 2x squared plus 1. Then we distribute the 4. So our final answer is 4x to the 4th minus 8x squared plus 4. Now if you're having troubles remembering, okay, do I put the g in for f or do I put the f in for g, look at your notation. Whatever function is on the inside is going to be what is replacing the x. So since I had the f of x inside the g, that meant I'm taking the f and putting it into g. If it was the opposite way around, if I had f of g of x The g is on the inside, which means I'm going to take the g and substitute it in for the f. Our last type of composition of functions is illustrated behind me on the board. I have f of x equals x squared plus 1 and g of x equals x cubed plus 2. My question is asking me to find f of g of 2. On the last two examples, we were either finding f of g of x or g of f of x. But if you notice here, this is asking me to actually plug in a number for x. So here's how we go about doing this. My g is on the inside, so that means I'm going to take my g and plug it in for f. But since it's g of 2, I have to do one thing before I plug g in for x. It's asking me to find g of 2. I'm going to plug in 2 in for x into my g function. So I have my g of x function. G of 2 is just simply means plug in 2 for x. So instead of having x cubed plus 2, I have 2 cubed plus 2. Two cubed plus 2 would be 8 plus 2, which is 10. So g of 2 equals 10. Now if I want to find f of g of 2, I just need to take this 10 and plug it in for f. Again, instead of having x squared plus 1, I now have 10 squared plus 1. And our final answer is 101. So in these types of problems, we're not just going to end up with a composition of function with variables. We're actually going to get a number answer. And these are all different examples of function operations. So you can add, subtract, multiply, and divide functions. You can also find composition of functions.